Welcome back to the second part of NC part programming. Generally, the programming in a CNC machine is done either as a manual part program or automated uh, programming. Here we are discussing about the manual part program. In manual part programming, uh, the transfer of an engineering blueprint of a product, especially a drawing, to a part program can be performed manually using a calculator or with the assistance of a computer language. If the program is complicated, it involves contouring operations, then manual part programming is difficult, then we will use the help of a computer language, especially CAM softwares, computer aided manufacturing softwares. The steps in part programming is explained as like here. The first, the machining parameters are determined. The machining parameters such as cutting speed, feed, and depth of cut. And in most of the cases, instead of cutting speed, we are actually setting the RPM of the spindle. That is actually expressed with a capital letter S. That is the RPM of the spindle is used. So RPM of the spindle, the feed rate for each and every operation and depth of cut is determined. And we know that the machining parameters depends on the type of the workpiece, type of the material of the workpiece, type of the tool material, type of the operation, condition of the machine, etc. And the second, optimal sequence of operation is evaluated. Sequence of operation means whether we need to phase the workpiece before turning, that has to be determined. Then whether we have to go directly for the step turning or plain turning has to be done, then the step turning has to be given, or when to do the thread cutting operation, when to do the taper turning operation, etc. So that sequence has to be evaluated. So again, we have to go for the optimum solution. And the third, after setting the sequence operation, we have to determine the tool path. Tool path means, for example, we are considering a simple step turning workpiece like this. Okay, a simple step turning workpiece. And turning the tool is actually fed from the rear side like this. So this is our first point. This is the point number 1. This is the point number 2. Then here it is 3, it is 4, here it is 5, and here it is 6. So these are the two points here. Okay, and in between that points it is straight line, so there is no need to give the intermediate points. And these points we have to give the coordinates, that is the x coordinate and z coordinate for each and every points. So that is the involved tool path calculation. So simple workpiece, manually we can calculate a tool path, but complicated workpiece tool path determination is very tedious. That's why we are going for the CAM softwares. Then finally, after determining the tool path, we can write the program. And a part programming contains a number of lines, and each line of the program is referred as a block. Each line is known as a block, which contains required data for transfer from one point to the next. The tool is transferring from one point to next, that point to the next, and that data is actually included in that each and every blocks. And a sample block is shown over here, and the various components of this block is explained in the next slide. The components of a program block is explained like this. The first letter is first component is actually started with the letter N, and that is actually the sequence number. Okay, N345, any integer can be used, or N100, 200, 300, like that we are using to show the sequence number, because sequence number, the importance of the sequence number is that in CNC program, the program is executing based on this sequence number. Then next is a code which is started with the letter G, and all the codes or the components of this program block which started with the letter G is known as a proprietary function. There are a set of G codes are available. Proprietary functions or otherwise known as G codes. This is a famous name, G codes. Okay, then it is followed by the destination coordinates, because we in the program block we are not mentioning the starting coordinates, because the tool is, we are assuming that tool is at the start of the operation, at the starting point. So we are giving the destination coordinates as x, y, and z for a milling machine, and for a lathe it is x and z only. Then next is f, another component which is starting with the letter f, and that is actually representing the feed rate. What is the feed rate? Then another is represented with the letter s, and that is the spindle speed. Then the T, letter T is used to give the idea about the tool. We need to study more about this code T because it contains more data about the tool. And finally, we are using another type of code that is starting with the M, and this is known as miscellaneous functions or miscellaneous codes, or otherwise another famous name, that M codes, because each and every machine carries a set of G codes and set of M codes, and using these G codes and M codes we have to perform the operation. Using all these codes in a program block is not mandatory. So whenever it is required, we will use that one. For otherwise, it is not required. Okay. Here it is explaining some letter symbols which are used in CNC part program, and most of the cases a percentage symbol is used to give the program number, because each program has got an identification, so that program number is started with the percentage symbol. Then n is, as said earlier, it is a sequence number of each block. Then G is the proprietary function or G codes. Then X is given for x-axis designation, like that. Y is for y-axis, and so on, and Z is like that. Then R is given as a radius designation. If we need to perform a curving, tool has to move in a curved path like this. So the radius of that curve has to be given. So that is represented with capital R. Then F is feed rate. Then S is the spindle speed. H is the tool length offset designation. D is the tool radius offset designation, and T is the tool designation. Okay, so what is H, what is D, etc. we will study at the last of this portion. And finally, the M is the miscellaneous function or simply M code. Now we will see what are the important G codes used in CNC programming. So it is G00 is the first one, that is the positioning of rapid traverse. That means whenever the cutting is not happening, when the tool has to move at a faster rate, because the tool initially the tool is at the tool hard position, somewhere away from the workpiece, so we need to call that tool near to the workpiece. So at that time it has to come at a faster rate. So there we are using G00 command. Then G01 means a linear interpolation. So linear interpolation means in the interpolation always the tool will move with the feed rate, because during that time it is actually performing the cutting operation. So what is the feed rate specified, that has to be used when we use this G01 code. And G00 code, there is no feed rate is specified. The speed rate is actually specified initially by the manufacturer. So the tool will actually move with respect to that feed rate. Then G02 means circular interpolation clockwise. That means whenever the tool has to move in a clockwise curvy movement, we have to use the code G02. And G03 is used for opposite direction. That is whenever the tool has to move in a radius movement, a curvy path with the counterclockwise direction, we have to use G03. Then dull means G04. That means we need to stop in between. So because after performing one block, we need some gap in between. So that time is actually ended with the dual command, that is the G04. And G17 and G18 are rarely used, especially for drilling operations. Then again, another important is G20 if we are using inch unit, and G21 if we are using metric unit. So initially we have to set whether we have to go for inch unit or metric unit. Based on that, we have to mention whether we have to use G20 or G21. Then another important this one is to nose radius compensation, and that will be explained later. The G82, sorry, G82, there are so many codes. Is to G87. Okay, these are actually used for canned cycles. Different canned cycles are available, and again, the details of canned cycle will be discussed later. And another important is this one, G90 and 91. G90 is used for absolute command, that is absolute measurement system is used. We have to use the code G90, and if we are going for the incremental measurement system, we have to go for G91. It has to be ended in the program. Then again, the G94 and 95 is for feed rate, and if the unit of the feed rate is feet per minute, we have to use G94. If the unit is feet per revolution, we have to use G95. Then again, these two are in connection with the canned cycles. The next important codes are M codes. So M codes are otherwise known as miscellaneous codes or miscellaneous functions. And here this M01, M02, M00, M01, M02 are not using commonly. That we will discuss later. And the most commonly used M codes are, one is M03, that is spindle on clockwise. By receiving M03 only, the spindle will start rotate. And M03 for clockwise rotation, M04 for counterclockwise rotation. And after the performing the operation, if we needed to stop the spindle, we have to use M05. Then tool change, because in a particular operation we are using different number of tools, because it start from facing, so it is we are using a facing tool, then a rough turning, so the tool is different, rough turning tool, then finish turning, a finish turning tool, like that. So each and every operation require different tools. The tool has to be changed in between the operations. So this M06 is used for M tool change command, and coolant on command is M08, coolant off command is M09. Then these all are connected with the subprograms, calling subprograms, etc. Subprogram calling Fanuc is M98 and it is M99 for Fanuc. And another important is M30. M30 is the end of the program and reset to start. So at the end of all the programs, definitely we have to include this M30. So M30 gives that the program ends there. In the next part of the video, we will discuss about the various compensations and offsets given to the cutting tool, and also the subprograms and canned cycles. Thank you for watching.